The width of an interval in PSICAT is determined by its grain size and the project's grain size scale, which you can see by going to the Edit menu, grain size scale. So this project has a very simple one. It has 3 ranges, silt, sand, and rock, with a maximum value of 3 and a minimum value of 0. And then on the left here, before the colon, it has a default width of 0.5, so that's think of it as a percentage. It's going to occupy 50% of the width of the interval column always. So even if it has no grain size at all, that much will draw. Those are grain sizes. For more information on grain sizes, please see tutorial number 8, which describes them in detail. This tutorial is about exporting stratigraphic columns using a grain size file. A grain size file allows you to override existing grain sizes or to apply grain sizes where none are defined in a project. You provide grain sizes to PSICAT with a comma-separated values, or CSV, file. This tutorial demonstrates the creation and use of this file. So, the format of the grain size file is as follows, if I can find it. There it is. Okay, so in the first row, you will provide a grain size scale, again as described in tutorial 8. And then this is followed by 1 or more rows with 2 columns each. The first is a lithology code, and the second is a grain size. As you can see, there will be 1 or more of these. The other important thing to remember about this file is that you should provide 1 row per lithology code, which is really lithology type, in your project, and I'll show you how to do that. Basically, you want to ensure that there are no duplicates. So, to start, we're going to fill in these things in a sort of strange order, but I think it will make sense once all is said and done. So, the first thing we're going to do is actually get our lithology codes from our project. And the best way to do that is to go File, Export, Tabular Data, and we're going to export a spreadsheet that has our codes in it. So we're going to do demo data stuff, export that to our desktop, and I will open that guy up. And if you go to the Intervals tab, that is where lithologies live. And I'm going to make this a bit bigger if I can find the, there we go. There we go. Okay, so in the Intervals tab, you'll notice there's a lithology column. I'm going to make that readable. Full of these not very human readable, at least in the front, strings, but in the end you can see that sort of what they correspond to. This is the lithology code for ore, not surprisingly. Here it is for oolitic limestone, and so on. So what we want to do is copy all of these lithology codes, and at that point we're done with this the tabular data that we exported, so you can hide that. So we're going to go back to our grain size file, and I'm just going to paste those values over these placeholders. Okay, so we now have all of our lithology codes. This is a good start. The next thing we need to do is make sure there are no duplicates, and you can see there are duplicates here. We have 2 ores, we have 2 limestones, so to get rid of those we're going to select all of our lithologies, and then in the data tab here, choose remove duplicates. And there we go, now we're down to 9. Each of these is unique. So that's a good start. Next we're going to define a simple grain size scale, again tutorial 8. I'm going to do something fairly similar to what we have in the project already. We'll do between 0 and 1 we'll call small, between 1 and 2 we'll call medium, and between 2 and 3 we'll call large. So there's our grain size scale, very simple. And now all we need to do is provide a grain size in this scale for each of these lithologies. So I'll call my oozes 1s, call salt a 2, and so on here. 2. So this is very inconsistent, but it doesn't matter, just to demonstrate. And at this point we're set. We have a functional grain size file. So what I'm going to do is save this. And make sure you save it as a CSV, not an Excel file. Default grain size is 2. Save that. And now we should be able to return to PSICAT and export a strat column using these grain sizes. So first I'm choosing my metadata just to determine what my strat column will be. So I'm going to use this sit from 7b. And so here is where you'll actually put your grain size file into use. Instead of choosing project grain sizes here, you'll choose grain size file here. That enables this, so now you can choose your grain size file. Choose this guy. And now you just need to choose where you're going to export it. So strat column grain size test. And I'm going to hit export, and we've hit a problem. There's something wrong with our default grain size file. Fortunately, I know what it is, and this is helpful. You may run into the same problem, so I figured I would leave it in the tutorial. I'll show you how to fix this issue. What we do is, the reason is that 2 rows have been left behind by the removal of duplicates. So what we need to do is simply grab everything that's actually filled, copy that into a brand new sheet, and paste that, and I believe that this should now work. Hopefully. Okay, so let's just, everything remains the same. Hopefully we should now be able to export. Hey, look at that. It succeeded, it was very fast. And now we can look at strat column. So as you can see, we have a range for each of our 3 ranges. We have a small, medium, and large here. Our oozes were at the top end of the small range, so that makes sense. They line right up. And as we scroll down, we should see that the salt is larger. That's the 2. And then we have some rock here that's 3. So indeed, our default grain size file is determining the widths of these lithologies. So that, in essence, is what a grain size file does. It allows you to override those settings in your project if you wanted to define things in a different way, or probably more usefully, to provide grain sizes when exporting a strat column when your project simply has none, which is not uncommon. Often groups don't have time to include grain size in their description, of course. So in this case, it's a way to at least provide some way to differentiate intervals widths based on their structure. Thanks for listening.